Buddy. Welcome to the section 2.5, 2.6, and 2.7 self-check. So let's go ahead and take a look at number one. So number one states the following data show the number of months patients typically wait on a transplant list before getting surgery. The data is ordered from smallest to largest. So here we have about 3 months to about 24 months. So we're given a couple of things we want to figure out: mean, median mode, standard deviation, and variance. So it's telling us to use a graphing calculator to calculate all these. So what we want to do is take this list of data and put them into our graphing calculator in that list. So let me pull up our calculator. So I already went ahead and went to edit and put this data in a list. So I'm gonna pause the video, give yourself a minute or so to enter this data in, and we can get going. Okay, welcome back. So hopefully you entered in the list correctly. And what we're going to do now is start calculating the mean, median, and standard deviation. So what you want to do is go to Stat, go to Calc, and then click on one bar stats, the first option. Make sure it's the right list. Frequency list is 0, and then go ahead and hit Calculate. So here's where our mean is going to show up. So the first entry is X bar. That's our mean. So our X bar is 13.948 dot dot dot. So let's go ahead and write that out. So here we have X bar equals 13.94. And remember that rounding rule where we go to one more decimal place than our original data. So since our original data is whole numbers, we're going to round up to one decimal place. And since a 4 is next to this 9, it's not going to round up that 9 at all. So what we'll have here is 13.9, and it would be months. And that would be the mean. Okay, so for the median, we are given the median in our calculator as well. It says median equals 13. So that's pretty easy. And what we would say here is median equals 13 months. Don't need to round or anything like that. Okay, mode. Mode is just, it's not in our graphing calculator at all. It's just the number that shows up the most in this data. So if you look at this, the number 7 shows up 4 times. The number 10 shows up 5 times. And everything else is kind of below that. 24 shows up 4 times. So 10 shows up most because it shows up 5 times. So here the mode equals 10 months because it shows up the most. Okay, standard deviation. Standard deviation is also given to us in our calculator. So let me scroll up. In our calculator, standard deviation is this S right here. This is XX. So here we're going to write SX equals, I'm going to write little s just because that's what we say outside of the calculator, for little s for standard deviation. And that's going to equal 6.35. And same thing with the mean. Since our original data is whole numbers, we want to round this up to one more decimal place. And so since we have a 5 next to the 3, it's going to round up that 3. And what this would equal is 6.4 months. Okay, so that's how we would do the standard deviation. Continue on to the variance. And variance is just our standard deviation squared. So let me um, say that. So it's just, I'll say SX squared, which is the same thing as S squared. And so what we're going to do is we're not going to take this standard deviation. We're going to take the whole number from our calculator. So that whole 6.35754 dot dot dot, and we're going to square that whole number. So let's go ahead and do that. So 6.357543046. And we're going to square this whole number. Let me rewrite that, sorry. 6.357543046. And this whole thing is squared. And what this comes out to, actually we could do it on the calculator here. So let me go to quit and we can do 6.357543046. And you want to press this X squared option right here. Press that, hit enter, and we got our answer. So what we get here is 40.41. Remember, it's one decimal place. And what this rounds up to is just 40.4 because that one's not doing anything to that 4. And that is how you would get the variance. Okay, so let's move on to question 2. Question 2, let me zoom in for this one. In a sample of 60 households, one house is worth 2.5 million. Half the rest are pretty low at 280,000, and all the others are worth 300,000. Which is a better measure of center, the mean or median? So in this case, the mean is when you add up all the houses and divide by the number of houses. Median is just the middle of your data. And notice here that we have 280,000 and $300,000 houses, and then we just have a random $2.5 million house. So this $2.5 million house is going to shift our mean to the right. It's going to pull that data to the right, and it's going to change what our mean might be, as opposed to the median, which is just the middle of the data. So in this case, I'll say the median is the better measure of center because the mean would not be a good measure since the house worth $2,500,000 will cause the mean to be too high. So I'm gonna bold that part because that's what is happening to the data. The $2 million house is making the mean too high because we're adding in that when we do our calculations, as opposed to the median, where median isn't a calculation, it's just the center of your data. Okay, so that's for number 2. Let's go ahead and check out problem 3. So here we have two swimmers, Angie and Beth, from different teams, and they want to find out who had the fastest time for 50-meter freestyle when compared to her team. Which swimmer had the fastest time when compared to her team? So here's what we're going to use Z-score. And remember that Z-score, the formula for that is z equals x minus x minus the mean. So I'll use that mu divided by the standard deviation, which is this symbol here. So that's our z-score formula. Let's go ahead and apply that to this question. And in the end, we want to see who had the higher z-score. So Angie, let's go ahead and check out her z-score. So Angie, we would have z equals her time, so 26.2 minus the team mean time, 27.2, all divided by standard deviation of the team, so 0.8. Okay, so let's go ahead and go side by side with our calculator. So we want to calculate, what you want to do is do the top first, so 26.2 minus 27.2, calculate that, and then just divide that answer by 0.8. And you get negative 1.25. So that's the easiest way to do it to make sure you're not risking any calculator mishaps, because calculator mishaps happen. Make sure to just take it one step at a time. No need to rush it all through. So that's Angie's Z-score. And let's go ahead and look at Beth. So Beth would be Z equals, her time is 27.3. Her mean time is 30.1. We want to divide that by the team standard deviation, which is 1.4. And we could do this calculation as well. So 27.3 minus 30.1. Oops, excuse me. I'm supposed to be doing that in the calculator. 27.3 minus 30.1. Hit enter. And then we want to divide this number. So answer divided by 1.4. And we get negative 2. Okay, so we get negative 2. And we want to see which z-score is higher. So essentially, negative 1.25 is bigger than negative 2. It's negative 2 is just a bigger negative number. So essentially, Angie has a higher z-score. And so what that means, so Angie has the fastest time compared to her team. Okay. And that's how you use z-scores to compare two different situations. Okay, so let's go ahead and move on to question 4. Go ahead and move on to question 4. It's conducted a study on the effect that playing video games has on memory recall. As part of her study, she compiled the following data, put into two columns hours teenagers spent on video games, which is our classes. So 0 to 4.4 hours, etc., and number of teenagers per each of these classes. So, what is the best estimate for the mean number of hours spent playing video games? So, since we have a frequency table and it's asking us what the best mean might be and successively the standard deviation and variance, what we need to do is get two lists. We need the hours spent be our list one, and the number of teenagers be our list two. So our hours of teenagers spending, we can't exactly get a number based on the table because it's a range of numbers from 0 to 4.4 and etc. So what we need to do is actually get the midpoints of these classes. So I'll just say list one equals midpoints, and let's go ahead and calculate those out. So the midpoint from 0.0 to 4.4. So 0.0 plus 4.4 divided by 2, and that comes out to be just 2.2. All right, next one is 4.5 plus 8.9 divided by 2, and that comes out to be 7. Same thing, we have 9.0 plus 13.4 divided by 2, and that comes out to be 11.2. Excuse me, I had a typo on this previous part. I wrote 7 because I was looking at the frequency, and that's the number I typed, but it should be 6.7. And so carrying on, we have 13.5 plus 17.9 divided by 2, and that comes out to be 15.7. And last one is 18 plus 22.4 divided by 2. And that comes out to be 20.2. Okay, so all of these are our midpoints, and these all go into our list one. And then our list two is the number of teenagers, so our frequency. So it would be 3, 7, 12, 7, and 9. Okay, so let's go ahead and put these values into our calculator. All right, so you just go to stat, edit, and let's put 2.2, 6.7, 11.2, 15.7, and 20.2. And we need to put in our list two as well. So 3, 7, 12, 7, and 9. All right. So the question's asking for the best mean. So what we need to do here is go to stat and calculate our mean. So we go to calc, one of our stats again, list one, but now we need to put in our list two. So we go to second and press number two. If you see above, there's a blue L2. That means we're gonna have that list two right there. So list two, go down and hit calculate. Okay, so we are able to get our mean. So our mean is, says here, let me type this out. It says X. So X equals 12.621. 621. And so our original data was one decimal place. So we're going to round this up to two decimal places. And so what this rounds up to is just 12.62. And this would be hours. And that's our answer. So the best estimate for the mean number of hours spent playing video games is 12.62. Okay, so within the calculations we did, we are able to get the standard deviation and variance as well. So standard deviation, remember it's that SX on the calculator. So it's SX, but we kind of just write S. And what that equals, let's type it out. So 5.644. And remember that we're going to round to two decimal places. So it should just be 5.64. And that's the answer. I'll say hours as well. Okay, so that's the standard deviation. Variance is just the entire standard deviation squared. So what we'll say here is variance equals, and it's just that entire number squared. So let's type that out. We'll do SX squared, which just equals S squared, which equals 5.644330228 squared. Let's go ahead and put that in the calculator and see what that is. So 5.644330228 squared, and we hit enter, and we get 31.858. So let me type that up here, 31.858, and remember it's two decimal places, so you want to round this up to 31.86 hours. Okay, so that is how you do question 4. All right, just list 1, list 2, and calculator. All right, let's move on to question 5. Last question of this self-check. So on a local softball team, the ages are as follows, and we have a couple ages here. So it says use our calculator or computer to find the mean and standard deviation. We're going to use our calculator. So take a second, pause the video, and enter in this list of data. Make sure to clear out your list. So go up to the top, hit clear, enter, clear, enter, and make sure to enter in your list. So I'm going to pause the video and go ahead and enter in your. Okay, so hopefully you have entered in your data correctly. You should have 21 up through 40. And so we want to find the mean and standard deviation. So what we want to do here is go to stat, move over to calc, one bar stats, and notice here we have list one. What we want to do is get rid of this list two. We don't need it. We're just checking out one list. And so we just go ahead and hit delete or clear. And then go down to calculate and let's calculate it. So the mean looks like the mean is x equals 30.68, that top number. And we have whole numbers here, so we want to round up to one decimal place. So this would be 30 point, that 8 rounds it up to 7. 7 years. So that would be our mean. Maybe I could write mean. And likewise, standard deviation, maybe I could write it to the right here. Standard deviation, and that is that SX in the calculator, which also just means little s, which also just means 6.09. And we want to round to one decimal place, so the 9 rounds up that 0 to a 1. So it becomes 6.1 years. All right, so that is our mean and standard deviation, and we're going to use both of these values to find the values about standard deviations above or below. So question B says, find the value that is 2 standard deviations above the mean. So what this comes out to is we're going to have a set of x. Let me zoom this in. So we have x equals our mean. So 30.7 plus we want to know is 2 standard deviations above. So it's going to be 2 times our standard deviation that we found. So 6.1. We're going to do this calculation. And what this comes out to is 47.9. So let me jump to the calculator and show you this calculation. Okay, so let's go ahead and quit. So 30.7 plus 2 times 6.1, and that comes out to 42.9. Typed in on 7 on accident. So 42.9. So that would be the value that is 2 standard deviations above the mean. So 42.9 is, I'll say, x equals 42.9 is 2 standard deviations above the mean. All right, so find the value that is 1 standard deviation below the mean. So below, what that means is we're gonna have the same setup, 30.7, and since it's below, it's gonna be minus 1, and also just times your standard deviation is 6.1. And what this comes out to, we could do it on a calculator as well. So 30.7 minus 1 times 6.1. That comes out to 24.6. So let's type that in. 24.6. And so x equals 24.6 is 1 standard deviation below the mean. But okay, so that's how you would do these below, above and below questions. So let me go ahead and maybe annotate. Wanted to change just a bit in question 4. Just say like mean, so know that we're talking about. But that's how you would do these questions for self-check. Kind of a long one, since we were doing about 3 sections, but hope you got everything down. And then thank you for watching. I will see you next time. Thank you.